Salam Doctor, we are from the Group 4 and today we will present about the fundamental of the transport and logistics. Our topic is rail transport and this is our group member. And today we will talk about the five key focus area. The first one is the KTM cargo current stack and the second one is the ECRL and the next is multimodal integration and the sustainability and the last one is recommendation.
Continue the limited capacity and outdated infrastructure of KTM Group. The first issue is the locomotive and fleet mismatch. Serve locomotive shortage. In the 2000 to 2010, the KTMB have maintained about 100 locomotives with an 80% daily active status, but currently only 23 to 25 of the fleet is operational. It's about 60% locomotive have been retired. The second is the freight car mismatch. There is the distinct lack of the dedicated modern container flat car required for the efficient transport of standard 20-foot and 24-foot equivalent units. This shortage actively disrupt flow between strategy and entry point from Padang Besar and major seaport, Penang Port and Port Klang. Going to the second issue, there's the track capacity congestion. The first is the passenger priority. Track accommodate ETS, commuter and freight. Passenger train are periodic, pushing center track utilization to 110% and causing serve freight delay. And then the second one is reconstruction disruption. Ongoing 2026, the project KVDT2 and Gemas Tumpat force temporary single track constraint and heavy resting capacity. And the last is northern bottleneck. Aging infrastructure cause a massive backlog of inbound container from southern Thailand via the Perai Bulk Cargo Terminal (PBCT). Okay, the last issue is the outdated management system. The first is the port yard management. The lack of automated tools lead to inefficient yard planning. Containers are frequently misplaced, improperly loaded, and out of system with terminal unloading sequence. And the lastly is the port to rail delay. The system grab trigger serve container congestion at Port Klang. This delay ship loading and force logistic company to revert back to road transportation.
I want to talk about the experience impact of the East Coast rail link on logistics effective. The 665-kilometer East Coast rail link is far more than just a railway. Under the National Logistics Master Plan, it's a strategic logistical engineer designer with a 70% focus on price revenue, delivering trees, claiming changing dividends. First, we'll talk about the conveyor transit. It shortens overland transport time from 12 hours to under 4 hours. Second, we'll talk about the maritime bypass. By directing linking Kuantan Port to Port Klang, carrier can entirely bypass Singapore shipping through point. Last, we'll talk about the 30% cost reducing. It estimates a 30% drop in transport cost compared to long-hour road trucking. However, the unlost dividend, we must bring three critical execution grades. First, the grid disconnect. The ECRL standard screw is incompatible with KTMB meter screw, forcing cost container cost docking at Serenda. Second, the last meter bottleneck. East Coast Station currently last Eastern container depot and local traffic, risking major terminal backlog. The third part is cross-border friction. Attaching this link to Thailand require over 2 billion in CapEx alongside compressed customer harmonization.
I will presenting the integration between rail, ports, and industrial zone. The integration between rail, ports, and industrial zone means connecting factories, trains, and cargo ship into one seamless network so that they can work together as a single system to move the goods faster and cheaper. However, there are some challenges and issues need to know. So the first is we need to know the current issue and challenges. The current issue is stakeholder coordination. For this network to work, port authorities, rail operators, and the government agencies must be fairly aligned. Right now, there is a lot of service uncertainties such as like industries don't know the exact freight cost, schedules, or loading fees yet. The worst thing is the ECRL track don't extend directly to the shipberth. So this will create an infrastructure gap where the containers must be offloaded to the yard and then reload again to the train. So this double handling creates the exact operational delays and we need to avoid. So the current challenges is implementation of the land bridge concept. So the ECRL is designed to link the Kuantan port on the east port and directly to Port Klang on the west port. This creates a shortcut for global trade by passing the long sea routes to slash shipping times across Peninsular Malaysia. However, a land bridge is only as strong as its weakest link. Its success relies heavily on the seamless rail port integration and fast cargo transit time. If there are any delays or inefficiencies at the port, so the land bridge lost the competitive edge and the international trade routes will simply ignore it. Next, We also need to know the strategic and technological issues. So the strategy issues is a strong competition with the road transport. In Malaysia, trucking is dominant because it offers flexible door-to-door service, but the rail transport is only competitive for long distance and high volume trip between the major hubs. So it completely lacks the first mile and last mile connectivity. Because of the industry rely heavily on the trucks, so we will face massive highway jam and high fuel consumption, increase the carbon emission. We also need to know the technological issues, that is rail infrastructure capability. We hit a massive technological bottleneck like gauge mismatch. KTM Cargo operates on a traditional 1000 meter gauge, while the ECRL use the 1435 millimeter standard gauge. Because of the track are different wide, train cannot physically cross over. This causes every single container must be mechanically transferred in at an interchange hub like Serenda, at Selangor, or Mentakap at Pahang. This will increasing the cost and complexity.
And today I'm going to talk about environment advantage of rail transport compared to road freight. In Malaysia, the transportation sector is the second largest source of greenhouse gas emission, road transport contributing over 98% of the sector. For example, heavy-duty vehicle accounts for 56% of road emission. In contrast, transitioning to rail network like KTM Cargo or ECRL offer a significant advantage, and we can look at the table below. Now look at strategy issues. Shifting Malaysia's logistical core from road to rail also meet some complex strategy challenges. The first one is the capacity choke dilemma. Malaysia's railway network has a very limited capacity because passenger trains like ETS or KTM Cargo and freight trains, they share the tracks together. The second is the 2% rules. If we transfer 2% of Malaysia's total road freight volume to the rail, the capacity demand of the rail would increase 25% immediately. If we transfer 4%, the rail network will be jammed and completely parasite. And the last one is the shipper habit. The truck transport can offer an unmeasurable door-to-door flexibility, so the shipper will not switch to KTM Cargo or ECRL Cargo for the environmental reason. Besides that, the rail transportation also meets some technological issue. The first one is track gauge incompatibility. This is the major and common in Malaysian rail transport. The KTM Cargo has used a line 1000 mm gauge, while the ECRL use 1435 mm standard gauge. Therefore, the trains cannot cross between the two lines. And the second technology issue is gear load and clean energy sourcing. As the Gemas to Johor Bahru, EDTP, and ECRL lines became fully electric, cargo trains will draw a huge amount of power instantly, putting a massive strain on Malaysia's power grid.
So for now, I will present about public-private partnership or PPP of employing rail connectivity. So the PPP is where a government and private company provide a support and funding support to make a transport is more efficient and improve our connectivity. So we can see the PPP can help to improve the connection between railway, port, and industrial zone. So we can see PPP have provide a better railway infrastructure. So for example, ECRL is connected with KTMB through a station like Jalan Custom, Serenda, and Mentakap. So we can see the better connection can make the transport and logistics more efficient. So we can see PPP also have developed in the model logistic hub that connect rail transport, port, warehouse, and industrial area. So we can see a logistic facility along the ECRL road and near major port can improve the movement of goods. So we can see better integration can help to reduce the cost, reduce the road congestion, and improve the efficient and competitive for Malaysia. So we can see PP also have expand rail freight capacity and depth. So PP can help to improve railway track, cargo terminal, and the freight flexibility. PP also has support the KTM freight and the ECRL project. So we can see a better rail infrastructure can make the transport more efficient, reduce the traffic and the pollution, and strengthen the Malaysian logistics sector. So we can see PP have passing a strategy. So first is scale on coordination because PP project have many people, so hard to coordination. Second is the financial and investment risk. So we can see high investment risk will affect the private company will release this investment. So third is the risk allocation. Government and private company must share a risk fully, not share fully will delay and higher cost. So next is the technological issue. We can first is the advanced technology integration because using an IoT, big data, and AI is so difficult. Next is the lack of technical skill. PP project need a skilled worker. A lack of expert can slow down the project. So next is smart transport technology. Smart transport technology can improve the railway operation, but is difficult to manage and maintain.
The next part is the recommendation or the future solution. To improve the rail transportation, the management can build the automated cargo transfers, such as upgrade the interchange station and using the scan system to foster the container transfers. And the second is improve the ECRL. The management can build the logistic facility around the ECRL station. And the third one is the green logistic subsidies. The government can provide the tax rebates or install the solar panel at the major rail station. The last one is the conclusion. The ECRL is the opportunity to improve the rail transportation. It's because it can give the green impact for our environment. It also can encourage all the people shift from the road transportation to rail transportation. This is all for our today. Thank you.